This is my Atari 7800. Recently I dug it out and found that both controllers did not work. And I know these controllers had a problem. It was a common problem where the plastic internal parts would break and not press the buttons to make the joystick move. But what I did is I rebuilt this one with metal and even a piece of wood, believe it or not. It works just as good, if not better, than when it was new. And we're going to go back to when I first tore these things apart to find out why they didn't work, so you can see how I did it. When you disassemble your 7800 controller, you're going to find your control board and the top, the base, 2 buttons, 2 screws, and most likely broken cross piece. This is what always breaks. And this rod is what this goes down over. Then your joystick top would go on that when it's in the body of the controller. And that's what moves this way. So what we are going to build is this piece. This is the only thing that needs rebuilt. But instead of one piece of plastic like this is, it's going to be made out of this galvanized steel plate. This is for electrical boxes. I believe it's a 1/16 thick. This has to be cut with a grinder or a hacksaw. Originally I made it out of aluminum, which did not work because even though it was a thicker aluminum, still very easy to bend, and then it would stop working after a few minutes. This is what's in the new one. It does not bend. The other material we're going to use to recreate this part is solid wood. In this case, a piece of oak. This is the part made out of oak. It's about a 1/2 inch thick and 3/4 by 3/4 square, and then I just kind of round the edges with a sander. It doesn't have to be perfect, just so it fits in this opening. That is going to recreate this part. And once I drill the hole down the middle, it'll go through this and the metal plate when we make it. Then I will kind of sand the top to give it a little bit of a curve like this has for when it goes up against this part. First, let's trace the broken plastic movement mechanism onto the galvanized steel that we're going to recreate it from as accurately as we can. Of course, using a Sharpie, it's fat and it makes a much bigger tracing than what you're going to cut out. So when we cut it out, we want to stay on the inside of the Sharpie lines. Let's make sure it fits in between the pins. That looks good. Nowhere's too tight, nowhere's too loose. So that will take the place of this. So next we need to drill a hole through the wood block and the metal separately. But we need to find the center of the wood block. I used oak for this because it's very hard, although I don't think this part is really subjected to a lot of stress, so you could probably use anything, even pine, I would think. The shaft could over time oblong the hole maybe in soft wood, but this should last a long time, if not forever. So I need to find the center. So it's 3/4 by 3/4, so we want to go 3/8. The pen works. Okay, and spin it. To make it easier, we'll go from a line instead of the lip. So there's the exact center of that. You almost... I think what I did the last time was took a skinny screwdriver and ran it down through the hole of this with it evenly placed over top and just made a scratch so I could, and that immediately gave me the center. We'll just put it in the vise. We'll lay the plastic original piece over it. And just make a mark with the drill bit that we're going to use. Okay, there we have our center. There we have our center. Can't really see it, but it did make a little mark. Too much glare. There we go. Right there. So now I can drill that, and I can drill the block of wood, and then this pin will fit up through. This is what is the actual joystick. File the burrs off the back of the hull. Take a round file just to clean up any burrs on the inside of the hull. Shaft should go through there. It's tight. So we'll just kind of ream it out a little more. We don't want it very loose at all. There, just enough to go through. But no side to side movement. Now when drilling the wood, we have to make sure that the bit goes through perfectly straight, perpendicular, and not on an angle. This would be better to have a drill press, but I don't have a drill press. Okay. Conveniently, everything disappears when you need it. I'm going to punch where the bit is going to start so I don't have it drift. So the drill doesn't drift. Just going to put a decent sized pilot hole there to keep the bit where I need it to be. Try to make sure that's straight in the vise. You can see it did not drill perfectly straight. It kind of leans. So I'm just going to oblong that hole just a little bit. I didn't really want it loose, but it needs to be perfectly straight up and down. And if I can make it straight with the oblonged hole, I can just shove a little JB weld in there when I get it where I want it. Let that harden, and that'll keep it straight. But that straightens up now, just by doing that little bit. Here's what we've made. This goes through here. This goes down over top of that. It sets in there, and this is our new control assembly. What I do is put some JB weld here between the metal and the wood to keep everything together. It will stay together without it, but this little ball end here sits in this cup on the controller, and that's what allows this joystick to pivot. We're going to take little dabs of solder and put little solder dabs on the end in order to recreate the little nubs right here that press on the actual control pad on the circuit board. Here, 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 and here. Let's mix up our JB weld. Now you could use epoxy too. Just happens to be what I have, and I know it's strong, so. Now this stuff, like epoxy, is 2 equal parts of hardener and resin. You don't need much. Okay, so that tube was at its end, so I had to use a pliers to get it out. A little bit more hardener. Mix it together till it's a solid gray color. No black, no tan. Just going to put a little bit where the wood's going to sit. I don't want it overflowing. It can overflow a little bit because you can take your finger and smooth it out to make a stronger joint if it squeezes out a little bit on the sides. Now I want to find the way that it fits best, because my cutout job obviously is not perfect. That seems to be good and centered. So now I just have to make sure that it's standing upright and not leaning. Which surprisingly looks pretty good. So we'll leave that set in the vise overnight. I'm going to take my finger and smooth that around. Make sure none's hanging out where it's not supposed to be. So now we're going to put some little globs of solder on the end to match the little nubs here that push the buttons on the controller board. So a little bit of rosin core solder. Definitely want flux. Put a little flux on the ends where they're going to go. They're going to be held in about 1/16 of an inch from the edge. Yeah, that's not quite high enough. I'm going to add a little more, and then I'll clean it up with a file and smooth it over so there's no rough edges or anything that could damage the controller. That's about what we're looking for. We'll make it a little smaller with the file. So just do that all around. Definitely need a little more on that one. Usually you have to do it at least twice to get it high enough. There's all the solder blobs sanded, filed, so that they don't cause any damage. Just kind of put a little bit of a bevel on the top to give it room to move. Let's put this back together. So this sits in here like that. See which way it goes best. I mean, that's pretty good. Just because it's not perfect. Actually, next we're going to take the top part. This cord's pain keeps trying to come down on you. So I'm going to put it up here. These wires to the side. There's two pegs that this board will clip on. Doesn't clip, but they go into the two little holes to keep it in position. This cord is a constant battle as you're trying to put it together. It keeps wanting to pop out of the little holder. These buttons also, because they're spring loaded, and when you sit them in there, if you don't get it, if it doesn't go together right, and you take it apart, they launch a lot of the time. So now we have to get this over the cross part. Meanwhile, that fights you, and then everything else flies apart. Alright, here's the beast assembled. Let's go try it out. Everything seems to move good. So now both controllers work great. They should last forever unless the electronics fail, but the mechanics probably won't ever fail with the metal in there. The first one came out perfect first time. Somehow it worked perfect. The second one I had quite a bit of trouble with. I had to make a lot of adjustments, which meant bending one of the arms up or down. At first it was trying to go two different directions. The things were touching that shouldn't have been, so I had to bend the metal arms back a little. And then at first it was too loose, and you could literally just lean the controller to one side and the game would start going to that direction. So that I tightened that up a little bit simply by adding some layers of electrical tape on top of the wooden block in the middle to tighten it up to the body. But they both work 100% now, so I'm hoping they last. Hopefully this helps someone.